Hello and welcome back. This time it looks like we're doing differentiation and we're combining the product rule and the chain rule. Let's have a read. Combine the product rule and the chain rule to differentiate each of the following functions. So let's have a look at question A first of all. So question A, what have we got here? We've got y equals x minus 1 squared times 2x plus 3. Okay, that doesn't look too bad. First of all, let's look at this as a product rule question. So this would equal, this would be y equals u times v. So u, our first function of x, is x minus 1 in brackets squared, and v, our second function of x, is 2x plus 3. So let's write that down. U is x minus 1 squared, and v is equal to 2x plus 3. Now u, not you the viewer, but you the variable, we've got a problem here. We've got x minus 1 squared. That we can't work out very easily. What we can do instead is say, well, u is equal to a squared. Now, a squared, this we can derive quite easily. We can say du dA is 2a. Well, I've just introduced a, so I better explain what a is. A is x minus 1. dA dx, though, would equal just 1. Now, why did I do this? Because I wanted to work out du dx. Now, if I tried to go directly from u and say, well, du dx is blah, that would be a little bit challenging. So what I've done is I've applied the chain rule within this product rule question. So imagine if the question just said y equals x minus 1 in brackets squared. Solve this. Well, you'd see that power, you'd see this x, you'd see this is a function within a function. So you might say, well, y equals u squared. Well, u is equal to x minus 1 dy du, it's just 2u, and du dx is equal to 1. Oh, let's make that u a little bit clearer. Perfect, nothing wrong with that at all. And then we can say dy dx is equal to dy du times du dx, which is 2u times 1, which is 2 open bracket x minus 1. Now we could expand that, but that's enough for now. So we've just applied the chain rule within the product rule. And quite often you'll see that if you've got a power attached to one of your brackets. So finally, we can work out what du dx is. And that will be du dA times dA dx. What is du dA? That is 2a, and dA dx is 1. Oh, one more thing. You might notice in our chain rule, usually you see it written as u. The function that you've identified is a function of a function. But because the product rule already uses u, we can't say u equals u squared. You're going to run into trouble there. So we've just used the letter a because it's a pronominal that we haven't used yet. So you could have used b, c, d, e, f, whatever, as long as you're not using something that's already been used in the question. So du dx, let's sub in what a is. That is just, what's a? A is here, x minus 1. Now, we won't expand that, we'll just leave it as it is for now. Now over here, we forgot about v. Well, we need dv dx, and luckily that's quite easy, that's just going to be 2. Now, what is our product rule? Our product rule, dy dx, remember, all the way up here we had y, we want to derive y. So we've got dy dx finally. And dy dx is equal to v times du dx plus u times dv dx. So I might just continue that just here. So dy dx is v. V is our 2x plus 3. Whenever you're substituting, always remember to use brackets. That way you can remember to multiply everything, and it helps you keep track of any negative signs. Let's see, du dx. Du dx is here. So we've got 2x minus 1. Then we've got plus u. U is x minus 1 in brackets squared, and dv dx is 2. Okay, good. Now let's work this out. Now, one really key feature of a lot of product rule questions is fully factorizing your answer. So let's have a look at that. So I can see in my first term, so this whole thing is my first term, and this is my second term. What is in common to both? I can see an x minus 1 here and here. So what I can do is I can factorize that out, and I'll put that out the front here. So x minus 1. And what will be left over in my first term? So my first term has a 2x plus 3. That's in brackets. And I had 2 times x minus 1, but I've taken that x minus 1 out, so I'm just left with a 2. That's my first term factorized. Now my second term, x minus 1 squared. I've taken one of those x minus 1s out, so I'm still left with an x minus 1. And I've still got a 2. Oh, that's very convenient. Have a look at this. We've got a 2 here and a 2 here, so we could factorize a little bit further. We can take the 2 out the front. We'll still have our x minus 1, and we will have 2x plus 3 left over, plus x minus 1. You can keep them in the brackets. It can be very useful just to keep them there until you're ready to fully simplify. So now we are ready to fully simplify this. We can just gather all the like terms. 2 open bracket, x minus 1 close bracket, 2x plus 3 plus x minus 1. There's 3 x's all together. The positive 3, the minus 1, that's minus 2. So that is the fully factorized version of the derivative of this. Now this fully factorized form is generally what is required because as these questions get more complex, you'll be asked to do more with this derivative. Now let's have a quick look. Well, maybe not a quick look. Let's have a look at another question. Maybe question E. E. So what is E? E is y equals x squared plus 1, 2x minus 4 to the power of a half. Alrighty, let's see what we can do in this space left over. So let me rewrite this in another way. Y equals x squared plus 1 multiplied by the square root of 2x minus 4. So the question may have originally said this square root of 2x minus 4, but differentiating that's a little bit tricky. If we change the square root to a fractional power, it's much easier to work with because we know we subtract 1 from the power when we derive. So let's work on that basis. So we've got u times v, still a product rule. U is equal to x squared plus 1. The u dx will be 2x. V is equal to 2x minus 4 to the power of a half. Well, this right here is a chain rule. So let's say it's a to the power of a half because we've got a function of x to the power of something. And those are quite common examples of chain rule questions. So now we can work out what dv dA is equal to. The power will come out the front, so it's a half multiplied by a, and we're subtracting 1 from that power. So a half minus 1 is negative a half. Hold up, I've forgotten to describe a. A is equal to 2x minus 4. And we need to derive this as well. dA dx equals 2. That one's a nice one. Alrighty, so we want dv dx. That's the whole point of applying the chain rule here, because we couldn't go from v directly to dv dx. If you've done a lot of these questions if you're used to applying the chain rule. Maybe you can, but while you're still learning, I'd say that this process of working everything out is very useful. So dv dx is equal to dv dA times dA dx. Let's sub in. We've got half a to the negative a half times 2. Well, a half times 2, that cancels out quite nicely. A to the power of a half. Sorry, a to the power of negative a half. I don't like negative powers. Let's just put that on the bottom. Oh, and remember, this is going to be the square root of 2x minus 4. Yep, that 4 is perfect. Fantastic. Now, let me just block this one off. Remember, we want dy dx. So dy dx, what is that equal to? That is equal to v times du dx plus u times dv dx. Now, we've got a lot of things happening up here. Maybe I'll just highlight some of them. So we've got u and du dx up here. I've got dv dx just here. And my v is just up here. Alrighty, that'll help me keep track of everything. So no, I want v first. V is this. So v is equal to the square root of 2x minus 4. My du dx, that is 2x, plus u is x squared plus 1. Dv dx is 1 over the square root of 2x minus 4. Remember, keep things in brackets just to help you keep track of any negative signs. Always a good habit. Alrighty, now, this is quite the mess. My goodness, let's see what we can do. I'll just scroll down. What can we do? Well, let's expand all the brackets. Let's gather up all the like terms. So this will equal 2x times the square root of 2x minus 4 plus x squared plus 1 all over the square root of 2x minus 4. Now this is not as simple as it could be. We've got two separate terms. We've got a plus in between this big term on the left and this fraction on the right. We can combine them both together. And we can do that by multiplying this left term. We can multiply that by the square root of 2x minus 4 over the square root of 2x minus 4. And that'll give it a denominator of the square root 2x minus 4, which allows us to combine our fractions. And luckily, there's a square root of 2x minus 4 on top, so we'll get rid of our square root sign there as well. So if we do that, we will get 2x minus 4 plus x squared plus 1 all over the square root of 2x minus 4. So we're almost done here. Let's expand the brackets and simplify it. So we'll have 4x squared minus 8x plus x squared plus 1 all over the square root of 2x minus 4. We're almost done. Okay, we can gather up the like terms here. So finally, this will be 5x squared minus 8x plus 1 all over the square root of 2x minus 4. And we're done. Let's have a quick look back from the beginning. We began with y equals x squared plus 1 in brackets times the square root of 2x minus 4, and we finished with this, which isn't that bad looking, but the process is quite long, but the process isn't difficult. There's a lot of opportunities for errors, but if you practice this, you should be doing a-okay. Alrighty, thanks for joining me. That's all we've got time for today, and I'll see you next time.